reactions that we're going to go over. Actually, there's like hundreds of different types of reactions. However, we're going to take a look at 5 of the most common types of reactions. So these do get just like a little bit confusing when we get down to single and double displacement reactions, but I'm going to do what I can to make it easier for you to understand what's going on. So let's take a quick look at this. So number 1, the synthesis one. Take a look at the general form at the bottom here. At the bottom it says, for the general form, it says A plus B yields AB. Okay, now what this means is that here I have an element, that's why it's A and not A and something else, plus another element, and that yields one compound. So I would probably add this to your notes to make sure you understand what's going on. So it may be something like H2 plus O2 yields H2O, and we balance that equation then. So that would be another example besides the carbon plus the oxygen, okay, and then yields CO2 like that. Okay, we have an element here, element there, element here. How do we know that it's just an element? Because we have one single capital letter. One single capital letter. Just like here I have one single capital letter, one single capital letter. When I have more than one capital letter, as in the H and the O, that means I have a compound. Okay, and we show a compound in the general form by showing you an AB like that. So let's just take a quick look at this. Here's another type of synthesis reaction, because I have potassium and I have chlorine. Now the fact that chlorine has Cl2 because it's Brinkelhoff does not change the fact that it's still just an element. And then that of course reacts over on this side here to form KCl, just one single compound as a product. Remember, the products are on the right hand side and the reactants are on the left hand side of the arrow. So here's a decomposition. I know I'm going through this pretty quickly, but I do want to show you. This actually should be written the other way around with the NaCl like that, and then that breaks up into Na and Cl, but we do have to make sure that it's Brinkelhoff. So when we break these two up, that means we're going to need 2 molecules of NaCl, actually 4 millunits, and then I'm going to have 2 Na on the side there. So here's another, there's all kinds of different ways that you can break this stuff up. Something like HGO is a compound because it's got 2 capital letters, 2 or more, and then it breaks up into Hg plus O2 like that. And I put a 2 and a 2 to balance that equation. Notice the A is the Hg and the B is the O2. Okay, the numbers, whether they're subscripts or coefficients, do not change the fact that they're elements. I know I'm rushing through this pretty quickly. I apologize. So here's another example of a decomposition. This is the one I just wrote down. I didn't do this on purpose, but it just happened to be this way. So 2HGO as a solid, that's mercury 2 oxide. And then this means that heat is used to break these two down. I get mercury metal, which is a liquid, and oxygen gas. Okay, moving on. Single displacement reaction. Now this one gets a little confusing, and here's what I mean by confusing. Notice that here in my example I have Cu as a metal. Okay, now we have to pay attention to metals and nonmetals again. Then I have a nonmetal and a nonmetal. So this is Cl2 like that, plus, and then zinc. Zinc is a metal. Because zinc is a metal, zinc is going to kick out the copper and replace it. So now notice that zinc is now the one that's mixed with chlorine, like this, okay? And then copper's by itself. That's a single replacement or a single displacement reaction. Excuse me. Here I have my metal, and here I have my nonmetal. And if this is a metal, which it usually is, then it kicks out the metal and takes the place. So it should actually be, yeah, they have this screwed up. This is not what you're looking at. What you're looking at is now I screwed it up. Hang on a second. I want you to change this and write this down. CB plus A. That's what it should look like, okay? Because this right here is A, these are B, this is C, so it's CB plus A, okay? So CB plus A. And it should be written like that with the C coming first. The reason why is because the C is a metal, and metals come first in compounds. Okay, moving on, here's another example. This is lithium and water. So when we have lithium and water, what we get then is, remember this HOH? Lithium kicks out the first H and is left with the hydroxide. So LiOH on one side and then plus H2O. Because of Brinkelhoff. All right, that's a single replacement reaction or a single displacement reaction. Both of those names mean exactly the same thing. Single replacement. Okay, good. So remember that for single replacement, I'm going to write this down again. Usually I write it down like this, and this makes a little bit more sense. A kicks out the B so that I get AC plus B. What this means is, let me choose a different, that A is an element plus a compound is what you're looking for. Element plus a compound. And then what you get on the other side is a compound and an element like that. So element plus a compound. I'm going to review all of this at the end here. I'm going to make a note. And then double displacement. So double displacement, notice for the general here, we have a compound plus a compound like this. And the A and the C are metals and metal, and they simply switch places. So A goes with the D, and C goes with the B, like that. So the A and C, or you can say the D and the B switch places, because the D and the B are nonmetals, like that. That's NM for nonmetals. So when we switch, when we go from a compound plus a compound, that is always a double displacement, not always. For us, that's a double displacement reaction, because it does get more complicated. Chemistry is a lot more complicated than this, so we're just doing the very basics. So that's a double displacement compound reaction. So double replacement, double displacement, always exactly the same thing. So it sounds like the foiling in algebra, where you take the first and last and then inside go together. That's one way to think of it. Notice the AG is the A, and the NO3 is the B, the Na is the C, and the Cl is the D. So I put A with D, so that's A with D, and C with B, just like that. A and C still have to come first in the product side because they're the metals and they're the ones that are written first in all correct compounds. So first of all, before we get to the practice, and we will get to the practice, you don't have to predict the products. I'm not going to do that. I just want you to tell me whether it's our choices are, and I want you to write this down. Synthesis, which is element plus an element. Decomposition, and then the products, which is just a compound. So no plus sign on the left-hand side for decomposition. Single displacement, I didn't get to combustion yet, but I'll show you that. Single displacement is an element plus a compound. Double displacement, which is a compound plus a compound, like that. Okay, so if I take a look at this, I have a compound and a compound because both of these have two capital letters, so that makes this a double displacement. Okay, I take a look at the next one, I have a compound plus a compound, so that makes this one a double displacement. Oh, these are all double displacement. My fault. I thought they switched it up. So what they want you to do is just when it says predict the products, you can put the H with the NO3 and you're going to put the AG with the Cl. That's all. But we're not going to do that. You don't have to predict products here. I just want you to be able to identify what type of reaction it is. Now let's talk about the combustion reactions. Combustion reactions are super easy, and here's why. I'm not even going to talk about the fuel, the oxygen, and something to ignite. I'm not going to talk about that because what I want you to see is exactly this. You have a CH compound plus O2 yields CO2 and H2O. Okay, so whatever it is, like whatever the example is, it's going to have CH like this plus O2, CO2 plus H2O. Always, always in products, CO2 and H2O, and it's always going to be plus oxygen. Those three things are going to be the same every time for combustion reactions. So when I take a look at this, here's one with pentane. I got C5H12 and then plus O2, CO2, H2O. This is the only thing that changes for combustion reactions. Of course, the numbers in front will change when this formula changes, but for the most part, O2 yields CO2 plus H2O. Always the same. We know it's going to be CO2 plus H2O here. It's always going to be the same. O2, CO2, H2O. So when I come to state the type and predict the product, so I have a compound and a compound. Compound plus compound, of course, is double displacement. I have CH compound plus O2 is going to be combustion, that's a CO. I have an element here plus a compound. Element plus a compound, if you look back through, is single displacement. I have an element plus an element, so that must be synthesis. And I have just one compound, and there's no plus sign like there are for the rest of them, and that's a dead giveaway, that's decomposition. Okay, you don't need to fill in what happens on the right-hand side. I just want you to be able to identify what type of reactions these are. So go through with the paper that I gave you and identify those using our simple, like double displacement is compound plus compound. CO combustion is the CH compound plus O2, and so on. And I think that's it. All right, thank you for listening.